Okay, guys, welcome to another one of our AP labs. This is going to be our acid-base lab on how much acid do we drink. Hey, I'm over here. So what we're going to do first is we're going to prepare the solution that we're going to use for our titrations. So what we have here is an empty bottle that I've cleaned and washed out. And then here I have some 6 molar NaOH that I prepped a couple days ago. And what I'm going to do is I'm going to use a certain amount of the NaOH to... you guys are supposed to do this dilution calculation in the pre-lab questions, but I'm going to take a certain amount of the 6 molar NaOH and dilute so that I have a solution of, oh heck, what did I do with it? Ah, here it is, sorry guys. So that I have a 1 liter of this approximately 0.1 molar solution. So what I'm going to do is I'm going to take the 6 molar NaOH and I'm going to take approximately 17 mils of it, which was, when I did my calculations, it was like 16.7 or so. So I'm going to put 16.7. You can't really get this exact. There's lots of reasons that are explained in the lab as to why you can't use the sodium hydroxide straight away. One is it is water absorbent from the surroundings, and so you can't get exactly the right number of moles using mass. So what we'll do is we'll standardize this against the KHP. But anyway, so what I have done is I filled this with fresh distilled water about 3/4 of the way or more, and then I have now added my 17 mils of NaOH, and I am going to take my my volumetric flask and fill it up to the etched line so that I have 1 liter of solution. So I'm adding up over here with the distilled water till just below the etched line, and then I'll use a wash bottle to do the last little bit. Maybe I can get in close there and let you take a look. So what I've got here is my etched line right up here. Hope you can see that. And I'm going to add distilled water until I reach, let me set this down, till I reach the etched line there, and then that will be my completed solution creation for my titrations. So there we go, bottom of the manette, just a tiny bit more. There we go. And so I'm going to take that and put it into the clean bottle. So I've labeled it kind of a blank molar NaOH. Once we do our, once I do the titrations and the standardization, I'll be able to write down exactly what this molarity is. We'll use this solution on more than just this lab. We'll use it on at least 1, possibly 2 subsequent labs. So here we go. I'm putting this in the 1 liter bottle, and I would have swirled that around a little bit, but since it was already up to the neck already and I figured I was going to pour it in here, it's fine. We can put it in this bottle here and then kind of turn this bottle, ooh, excuse me, kind of turn this bottle around to kind of mix the solution. So I'll mix the solution slowly, not sloshing it too much. Don't want to grab any CO2 and mix in there with the NaOH. So we have our solution now. The next thing I'm going to do in this video is I am actually going to go ahead and do the masses for the potassium hydrogen phthalate that we'll need for the standardization. So I'm going to back up a little bit, and I've got the potassium hydrogen phthalate kind of set up over here. So this is our solution we're going to use. And over here we've got 3 different trials that we're going to do for KHP. Trial A, trial B, trial C. Let's see if you can actually see. Yeah, you can kind of see that. So trial A, trial B, trial C. And then over here, this is called a desiccator. And so what this does is it has calcium sulfate in the bottom of the desiccator down here underneath this grid. And what it does is it absorbs water from the surroundings. It's hygroscopic. And so the KHP here has been dried in an oven and left in here so that it didn't actually absorb any more oxygen, or excuse me, water vapor from the air and change the value for the KHP. So, and KHP is an excellent monoprotic acid to use for these large molecular weights, and works really well for our standardization to find the point at which we have the same number of moles of S as moles of base. Anyway, so I'm going to come over here to the balance. Let me see if I can get you guys a little closer, and I'm going to mass out the 3 masses that I need for this. So let's put this right here. Here we go. Oh, you can't really see. Should have thought this through. Yeah, that's pretty good. That's pretty good. Okay, so what I'm going to do is I'm going to first tare my balance and or zero my balance, and I'm going to do the one for solution A. So you're going to have to write down with every significant figure we have here to 4 decimal places what the mass of the KHP is that I add, because they won't be the same. We're somewhere between, I think, 0.4 and 0.6 grams for each trial. So I'm going to move this back and add a little bit of the KHP to get to that mass. So we're at 0.25. That's pretty good. So for trial A, which we're going to do as our first trial, you're going to write down 0.5549 as the mass for that KHP, 0.5549 grams. And now I'm going to go ahead and, I'm going to go ahead and do a second trial now for B. Go ahead and mass my B as well. So I'm taking my B, let's tare my balance. And I'm going to add another between 0.4 and 0.6 grams, so somewhere around 0.5 grams or so. Wow, that's too much, Tolan. We're going to have to do that again. Let's do that again. We'll dump our substance and start over using the same pan. So we're going to go to 0.5. We still had some left in there, that's why it's 0.0125. So we'll add this here. That's fine. So 0.5479. So 0.5479 grams for your KHP for the second trial. And then we're going to go ahead and set up for trial 3. So we're going to take these 3 individual standardizations and then average them together at the end to tare that balance. All these weighing boats don't have the same mass. Okay, so we're going to add, let's see. That'll work. So we'll do that there. So 0.5612. We'll use 0.5612 grams for our KHP for trial C, or the third trial. So there you go. So you'll need to write those down in your data table, and I'll come back and show you the titrations. To kind of show you our apparatus here, we're going to do 3 different titrations. This will be for trial A right here, and then we'll do a titration for trial B right here, and we'll do a titration for trial C right over here. And we'll do those a little bit later today. I'll come back in a second video, okay?